Hello, everyone, and welcome to the MIT Vision Seminar. Today, it's a pleasure to have Professor Devi Parikh from Georgia Tech to talk about some of her work on vision and language and show some of the starting work at the intersection of AI and creativity. The seminar today will be a bit different than normal, and the idea is to make it more interactive and more like a conversation. So we encourage people to kind of like leave comments and questions throughout the talk and make it as much of a conversation as possible. Devi Parikh is an associate professor in the School of Interactive Computing at Georgia Tech and a research scientist at Facebook AI Research. Prior to that, she was an assistant professor at Virginia Tech, and before that, a research assistant professor at the Toyota Technical Institute of Chicago. She has held visiting positions at Cornell, UT Austin, MSR, CMU, and Facebook AI Research, and she did her PhD and master's at CMU. Her research focuses on the intersection of computer vision and language, embodied AI, and human-AI collaboration, as well as AI for creativity, where she has done a lot of really fantastic work. She started the task of VQA, as well as visual dialogue, using abstractions for common sense knowledge, and a lot of really great works on embodied agents, including embodied question answering or embodied visual recognition. And for that and a lot more, she's the recipient of many awards, including the NSF Career Award, a Sloan Research Fellowship, multiple Google Faculty Research Awards, and being listed in Forbes' list of 20 incredible women advancing AI research. Devi, it's a pleasure to have you here, and all yours. Thank you.
Thank you. Thank you for having me and for that very nice introduction. Let me go ahead and, so like, it would be nice if this is more interactive as opposed to me just sort of talking at you guys for an hour. So I do have slides, and I'm afraid that as soon as I launch them, we will get back into the mode of me just talking. But to the extent that you feel comfortable, please do interrupt with questions, comments, anything like that, and I'll try and check in to see if there are any questions at any point. And this is, I don't have sort of a very formal deck, it's just a set of slides that I'm interested, things that I'm interested in talking about. And so, but hopefully you'll find it useful. So let me share my screen again. All right, and so hopefully you can see my screen, and I'm just going to dive right in. So in vision and language, the main thing that I want to talk about sort of is motivated from the fact that a lot of the progress that we've seen in vision and language, sort of image captioning, VQA, visual dialogue, other things like that, for each one of these tasks, as a community, we've sort of followed this recipe that whatever task we want to study, we collect a data set for it, we figure out what an appropriate model architecture would look like, we train the model on that data, and then we see good performance, and then we go on to a different task and kind of repeat, right? And so it's been somewhat successful, but it's also a little strange in that one would expect that the underlying visual linguistic representations that we want to learn should be somewhat task agnostic, that should be somewhat generic. And then sort of the reasoning that is required for those specific tasks, we might want to do in a task specific way, right? And so this is sort of what is very common in computer vision, right? We often pre-train on something like ImageNet, and then we might fine tune for other tasks. But that recipe hadn't quite been figured out for vision and language. And so what we wanted to do, and so as a consequence of that, some things that might happen is across these different models, these visual linguistic representations might capture different things, right? So for this image, if you ask a VQA model, what type of plant is this? It might say banana. But then if you ask a captioning model to caption this image, it might say a bunch of red and yellow flowers on a branch, right? Now, in this particular example, I've gotten feedback that, well, maybe even humans might be confused about whether these are bananas or flowers, and so maybe this is reasonable. So I think I should find a better example for this. But my main point being that it seems strange that a VQA model thinks a certain patch is a certain object, but then the captioning model thinks something else. And so what we wanted to do was to learn a common model for visual grounding that we can then leverage for a variety of vision and language tasks. And so we did this. I won't get into the specific details of this. It is sort of what you might expect if you're familiar with BERT and other models like that, where we wanted to see if we can pre-train these representations and then use it for a variety of tasks in a fine-tuning setting. And so we did this on conceptual captions. It's a large data set with images and captions. a few things that you have to take care of when you try and do this across vision and language is that both modalities are at different levels of abstraction. And so we have this two-stream model that processes them separately. And so what I mean when I say that two levels of abstraction is that in images, you start from pixels where there isn't a lot of semantic information to begin with, whereas in language, you might start with words that are already very close to the semantic meaning. And so you have to have a reasonable way of dealing with that. And then we have some co-attention mechanisms to fuse this. So Wilbert was the model that we had proposed. There were many models that came out all at about the same time, which were essentially BERT-like models for vision and language with very similar ideas. And so we then applied this to 5 downstream tasks. At the time, it was state-of-the-art on all of them. And then we sort of pushed this forward. So in this setting, it is still the case where we learn a common generic set of visual linguistic representations, but then we fine-tune for every downstream task, which means at the end of this, even though the underlying representations are somewhat common, you still have a separate model for every task that you care about. And so we wanted to push this further and see if we can have one model, just sort of truly one model that does all of this at once. And so we did this for 12 different tasks. You can look at the details in the paper. I mainly want to show you a demo of what this looks like, so I'm trying to get to that point. And so what was interesting is that it's not obvious that training one model on all 12 tasks will actually do better on the individual tasks. You might end up compromising on accuracy. But what we found is that with the right tricks to train this model across these 12 tasks, you end up having higher performance on all 12 tasks with the model being 1/12 the size, because now we don't have 12 different models for it. And now you can still take this one generic model and fine tune it for every task if that's what you care about, in which case we had state of the art on 7 of those tasks. And so what this means is we now have one model where you can feed it an image and a question and it will answer it. That same model, you can feed it an image and a referring expression, and it will draw a box around where that object is. For the same model, you can give it an image and a caption, and it will score it and tell you how good that caption is, and things like that, which I think is quite exciting. Let me try and switch to showing you a demo of this. You can see my browser now, right? Yeah, okay. So this is wilbur.cloudcv.org. So you guys can, maybe not all at once right now, but after my talk, you can maybe try it out, and you can try it on any image on any one of these tasks. And so let me see so I've picked out a few images to show you these things on. So you can upload an image and you can pick any one of, I think we have 8 different tasks listed here. And so you can have your regular, let me zoom in just in case it's too small on screens. You can have VQA tasks like where is this picture taken? It says kitchen. For the same model, you can have a spatial reasoning task, which in terms of the API looks like VQA, but it's a different, it's been trained, the capability comes from a different data set. What is behind the man? It says refrigerator. You can do a pointing question like, and which object is red? And so for a pointing question, the answer is not natural language. It's supposed to point to regions that are the answer. And so here it's highlighting, I believe, the red shirt. Here is an apple. And this is an entire region that has several red objects in it. You can do referring expressions. Like you can say the boy. Then it should draw a box around the boy. You can say the girl. And it draws a box around the girl. Referring dialogue. And so this one is, it's set up as sort of for 20 questions. And so you're supposed to give it a string of question and answers, and it should give you as a response the object that satisfies that. So I don't want to type it all out, but I'll just copy paste this template and say, is it edible? And the answer is yes, which means we are looking for something that's edible. And is it red? And the answer is yes. And so we're looking for something that is edible and red, and it should draw a box around something that is edible and red, and it draws these boxes around the apple. We can change this to no, so we're looking for something that is edible but not red. and it draws boxes around these bananas. Visual entailment, you can say this family looks sad, and so that's in contradiction with what the image seems to be showing, so it should say false. I have a couple of tasks. I know this is taking a while, but hopefully you're finding this useful. I can also then take sort of queries from you guys if there are any images or inputs that you want to try. So this is a task that has 2 images. And so when I give it a caption, it's going to respond with respect to these 2 images. So if I say both images have 3 people in them, that's not true for this pair of images. And so hopefully that's what the model should say. And so it says false. And if I say the image on the left has 3 people in them, it says true for that, right? And the last one, that's an image retrieval task. It can take up to 4 images as input. And so here I can say, I don't know, the peaceful scene. Most of us might agree that maybe the beach scene is, actually, I don't know, other images in this could also be peaceful. But let's see what it says there. So yeah, it returns the beach scene. And so this I thought was exciting, that we finally have one model that can handle these different vision and language tasks. So I don't know, does anyone in the audience have inputs that you would want to try on any of these images, or there's also random images here that I can sample through?
So I have a question about the model. This is the same model for all the tasks, right?
Right.
And does the model know explicitly the kind of task you're feeding at every time, or there is like it infers from the input?
It does have, so it is the same, most of the model is the same. It has a deep backbone that is the same, and then there are very shallow layers that can handle essentially the API difference, that in some cases it's taking a question and it needs to produce an answer, in some cases it needs to give you scores around bounding boxes. So there are shallow layers on the top that handle these different APIs for the different tasks. And so there is a task token associated with that indicates which task you're looking at. We could set it up where based on the input, it can probably guess what kind of a task it is. But yeah, right now that is specified through a task token.
And do you have thoughts about because there are all these like shared parts in the model? Do you have thoughts of, or normally all these tasks are treated separately? Do you think that there could be value in having some kind of problem that is a combination of 2 tasks, like maybe pointing in one part of the image and also giving some description or something along those lines?
That's interesting. And I guess there is some, from like a interaction perspective, that might be natural in some cases, right? You might first ask, is there a certain object at all? And then if the answer is yes, then you might say, okay, can you point to it? And so I think for those settings, it might be natural, and even from a dialogue, right? There might be a dialogue that's back and forth, and at the end of it, you might ask the agent to then actually point to the object. So I do think it might make sense from an interaction perspective to have a mix of these tasks. Evaluation gets tricky. I think evaluation as is tricky right now for some of these things. And so the more tasks you combine into it, that would probably get harder.
So
Yeah, we can hear you.
Okay, sorry. I have a question. How, if you now come up with a new task, like would that basically just amount to adding another one of these shallow layers? And does that, like, does your backbone or your representation kind of generalize just to completely new tasks?
So in theory, that would be the idea. We have not tested that. So in practice, I don't know how well that would work, but that essentially is sort of the idea here, that the hope is that someone can take our pre-trained visual linguistic backbone and then add this extra shallow layer on top of it for a different task. And it should do reasonable things. Given that it has been trained on quite a few tasks, I suspect that it will probably do reasonable things, assuming the new task that you have is somewhat related to the kinds of tasks we have here. And so I think my intuition is that it should be reasonably successful. but we haven't explicitly tried that.
I have a question. Do you have thoughts on like how, or maybe you've done this, like how interpretable it can be? Like when you say there's 3 people on the left image, like, can you look at the layers and like see if it's doing what you'd expect, or things along these lines?
Yeah, we've done a little bit of this for, especially in the first Wilbert work, which was the first time we trained these visual linguistic representations through these transformer models. And we do check for what words get mapped to which patches in the image. And those often look reasonable, they look reasonably interpretable. We haven't done it for more complex phrases like 3 people and getting it to show us exactly where those 3 people are. Actually, that's what, yeah, I was going to say that's what kind of the referring expressions, we could try that here.
And like if you said there's 2 people on the left image, would it be a lot less confident in its prediction?
Let's try that out. So let me do the 3 people thing first. And so this was the image caption. And so there are 2 people in the left image. So in general, these models, their confidences are not very well calibrated. So it says there are 2 people in the left image and it says false with 80% confidence, right? And you want to compare that to there are 3 people in the left image, right?
Yeah, or maybe do 4 people because technically there are 2.
Oh, I see. Yeah, that's a good point. So there are 4 people in the left image. Yeah, it is more confident that there aren't 4 people than there are 2 people. We may have gotten lucky on this one. I don't believe that these confidences typically are very well calibrated. But in this case, it does seem to have done it. And what was your earlier question that we were going to try?
I don't remember.
Okay.
Is it possible to do like there are 2.1 people in the left image? Like I just wonder how does your model handle these like other floating points or something?
Yeah, no, I don't think it does anything reasonable. I mean, it will say something and it might look reasonable to us, maybe not, but I don't think it's actually doing anything intelligent with the, I don't think it has a sense that 2.1 is closer to 2 than it is to 3.
I see.
Yeah.
Could you try exactly 2 people in the left image?
And so it should be more confident of that being false, right? There are exactly 2 people in the left image. It is more confident of that. Maybe I'm underestimating the probabilities of these models. Yeah. Oh, I now remember what we were going to try. We were going to do the referring expression with 3 people to see where it thinks the 3 people are. So that's one other thing that I like about this model, that because you can poke at it from these different tasks, it gives you some sort of interpretability through that. So, I mean, a large percentage of the image is covered by these 3 people. So wherever it draws the box, it's actually not all that good. None of these boxes cover all the 3 people. I wonder if this changes it. Yeah, not really. So yeah, it's not doing a very good job at drawing a box around all 3 people.
I have a quick question.
So
given that there are many different tasks, it seems like all of these tasks still require the same kind of reasoning. So did it happen that when you added one of the tasks, the performance actually was worse? Like, was there any task which required some kind of different reasoning, which did not really?
That did happen. We had grouped these tasks into 4 different groups. And what we found was that what we were calling the 4th group, which I think was these visual entailment, I think it was one of the visual entailment-like tasks. And adding that in was hurting performance on other tasks. And the interesting thing was the other tasks were helping this task, but this task was hurting the other tasks. We tried to poke at it to get a sense for what's going on. We don't have very strong intuitions for why that might be. At a high level, it might be something like what you're saying, where sort of the reasoning is somehow in conflict with what the other tasks need. We were trying to get to what exactly that might be and what does it mean to be in conflict. We don't have very strong intuitions on that yet.
I see.
Could you give us an example of one of those tasks, please?
So that was this, the visual entailment task, where you are giving a caption for an image, and it's saying whether the caption contradicts with the image, whether it's neutral with respect to the image, or whether it's consistent with the image.
Thank you.
I have another follow-up question. So when you see it fail, does it just fail without, does it still fail within, so what are your thoughts about how it fails?
You mean in the context of the specific task, or just in general?
No, in general, across the tasks.
So one thing that happens in vision and language models in general, which has been getting better, but I think is still an issue, is that the language-based priors tend to be much stronger. And so many times it will answer a question in a way that seems plausible based on the language, but you can tell that the model isn't quite grounding the answer sufficiently in the content of the image. So this happens much less now, and so this is not a very good example. It's more like an extreme example, but just to give it, early on when the VQ dataset was released, some of the early models that were trained on the model, on the dataset, when you ask how many of anything, the model will usually just say 2, because most of the times when the question was asked in the dataset, the answer was 2. And models had just latched onto it, and it took more effort than one would maybe, or at least I had imagined going in, to get the models to actually look at the image to answer the question, rather than just relying on the priors from the question. Another, perhaps more forgiving example is, what color are the bananas? The answer usually is yellow, so it's reasonable for the model to just build a prior and say that whenever somebody asks me about the question of bananas, I'm just going to say yellow. But every so often there will be, say, green bananas, and the model will get that wrong. And so it's hard to figure out how to get these models to actually look at the bananas to answer the question when the prior is just so peaky.
I see. Okay, thank you.
So how well can these models deal with sort of uncertain labels? So if you say, how instead of asking how many people are in the image, if you say just how many things are in the image, do you usually get something reasonable, or?
We can try it out. How many things are in the image? Yeah.
Okay, maybe.
Yeah, I'm surprised it didn't just say like many. It does that sometimes, where if you just say like how many people are in the image for a scene that's crowded, it might just say many. And the reason is that's how people may have, when the data set was collected, that's how people may have chosen to answer the question. In general, with there being, I think when you were saying, I think you were essentially saying that if there could be multiple true answers, how would the model handle it? I think it can do that okay, because the training data has that. For every question, there were 10 people who answered that question, and it's very rare for all 10 people to have said the same thing. And all of that data has been fed into the model during training. So it has seen multiple plausible answers to the same question. Yeah, to what extent it replicates that in its predictions, I think is still an open question.
How was the task done where you have to specify between the left and the right image? Because that's like a 2-part prediction, right? Like you have to first decide which image. Or like it has to understand the fact that you said left image in your sentence.
Right, but I don't, so there isn't, the pair that is being fed in is an ordered pair. And so I think it just, in the training data, it has always just seen the left image as image 0 and the right image as image 1, for instance.
So if you say left like anywhere in the sentence, it'll probably know what to like look at, I guess.
Yeah, as long as it's grammatical, because it's only seen. Yeah. It's only seen grammatical sentences. So it's not using left as like a keyword or anything, but yeah.
Yeah, thank you.
Should be able to pick up on that. Yeah. Any other questions? All right, thank you for asking those questions. I will. So I just wanted to sort of briefly touch on. So I personally am very excited about this. When vision and sort of a few years ago, this was not at all the state of what models could do, and so it's exciting to see the kinds of things they can do. There's still sort of many open challenges, including things like I was saying earlier, where it's hard to get the models to be grounded in the content of the image. But I think and there's been quite a bit of work on that. I think certain other things where there hasn't been much of any work at all, maybe very little work, that I think is somewhat concerning, is the fact, one example is that many of these tasks, if not all, are based on COCO, the COCO data set that I assume many of you are familiar with. And so that I think is problematic. We really don't have a sense for how these models will generalize to kinds of images that may not be sort of consumer photos from Flickr, sort of filtered down around these 80 categories. And so I think that is, it would be good to see more work in this direction so we know how good these models really are. Another direction that has seen a good amount of work, but I think still doesn't, I don't think there are still sort of clean solutions to this, is how we can incorporate external knowledge into these vision and language models. So questions like, what can the red object on the ground be used for? You can't answer that question just based on the image. You might recognize that it is a fire hydrant based on this image, but then you need access to some external source of information that tells you what fire hydrants do, what they can be used for. And so there hasn't been, so here are a few examples of work that have been done in this direction, but I think there's much more to be done there. Another thing that not much has happened in this direction is sort of these vision and language models. The way I think about it, and the reason there is natural language involved is because we expect humans to be interacting with these systems to get something useful done. But all of, if not most of the, so most if not all of the evaluation that happens for vision and language tasks happens very much in this standalone benchmark data set where evaluation is done without a human in the loop. And I think that can be problematic. And so we've been doing some work where we set up sort of a human AI game that you're seeing on the left here to see how humans and machines can work in collaboration. A few other examples are seen here, but I think there's quite a bit more that can be done in building models and evaluating them, keeping in mind that these are being built for humans to use for some task that they care about. Another thing that's lacking is that sort of whenever we talk about vision and language, we often use as a motivation, we say that, oh, this could be useful for visually impaired users who may not have access to the visual data, but through the language can get the information that they need. And there's been very little work done in this direction. This one notable exception is what you see here, the VisVis data set and task around it. But I think there can be much more that we can do here, specifically for these applications where the kind of data that you get is very different, again, from the kind of data that we would have from COCO images. And so I think more can be done there. Most of the work that goes on in vision and language is in English as a proxy for natural language. There's been some work that I'm aware of in other languages that you see here, but I think much more can be done there as well. And lastly, there's been some early work on studying the kinds of biases that these models have. So these data sets have images that tend to be very biased based on sort of societal biases. They have language that also tends to be very biased, and it has both of those together. And so studying what these models are picking up on, what we can do to try and counter the bias to some extent, to the extent that machine learning models can. I think there's more that can be done there, and there's some interesting early work that I've shown on the slide here. All right, so that's all I have for the vision and language part of this. I think it's a very exciting space. There are several important applications, sort of real world applications that would be exciting to look at. There is a lot of room for sort of new task definitions, new data sets, figuring out how we should be evaluating these models in the first place, looking at bias, looking at human AI teams. And so I think there's a lot of exciting work that can be done here. It's pretty exciting what we can do today. You can try the demo further if you'd like. but I think there's also lots more to be done here. So any questions on this piece before I move on to the AI and creativity piece?
So I have a question about the different languages. Do you, like, would you expect there to be some strong, like, functional differences when you, like, when it comes to maybe using languages that have sort of, that's not just, I don't know, English and French, but maybe, you know, maybe languages that really have some fundamentally different ways of expressing things like spatial relationships or numbers or groups or things like that. So would you, I mean, would you expect there to be, I don't know, interesting things coming up when kind of you look at these languages and maybe how they are grounded to visual data, that there are maybe different, just different paths or different kind of expressivity?
Yeah, I think so. And so I think it could be sort of functionally different in the way that you were saying, that how you refer to sort of spatial relationships or things of that sort. And there's also the issue that different languages have different levels of expressivity for different concepts. So I think Alyosha Yufros, I think, was the one who gives this example that, and I may not get this entirely accurately, but I think in Russian there's like 7 different words for different shades of blue to essentially refer to sort of different formations of ice, whereas other languages may not have that. And so I think even sort of figuring out how to ground those different granularities of ways of talking about different concepts would be another thing that would show up if we look at different languages, that might not show up if we're looking at just English. It's also interesting to think about, so some of the different function forms that you were talking about, they may have been picked up by machine translation approaches. So how much of it can we get away with if we were to just translate a language to English and then connect to vision? Whereas the example that I was giving, it might be harder to get away with that because the thing that is lacking is very much like the 7 different shades of blue. Those need to be resolved through connections to vision. And we might, because English doesn't have that, we wouldn't be able to get away with machine translation approaches. It's also interesting to think about what just the language alone can capture by going from one to the other versus what really needs to go through the vision modality. Any other questions?
I had a question, and this is like more related to maybe, I was curious about your thoughts on interface between like vision, language, and learning. I think like nowadays, I've seen like some works in more of like human-robot interactions where the human tries to sort of break down tasks. So let's say like a task is to go to the refrigerator and get like a milk carton. And the robot might not know how to initially do that task. And so the human has to sort of break that down into like move to the kitchen, move towards the fridge. And that's a very expensive way of sort of teaching what a task even means. And I was curious about sort of what are your thoughts on different ways of interfacing, you know, how to use vision and language to maybe in a less data expensive way to essentially teach these more complex tasks, break them down. Yeah.
That's interesting. One work that comes to mind that I saw recently was where they had humans move their mouse over different regions of the image as they were describing it. So if I'm saying there is a tree next to a giraffe on green grass, then I'm hovering over the tree when I say tree, over the giraffe when I say giraffe, over the green grass when I'm saying green grass. And that to me had come across as and so the counter of this would be that when we try and collect dense annotations to get associations between individual image regions and language, we would have to go in and someone would draw bounding boxes around every object,
Right,
or they might
yeah.
segment the image out and then associate language with each of those things. And instead, this interface where someone is just sort of hovering their mouse over the whole image, I thought was a neat way of collecting a lot of rich and fairly dense association between language and images through the hovering of the mouse. It's not quite getting to your question because you were talking about using language as a way of teaching machines something that is not all that data expensive, right?
Yeah, but I do think the pointing is a really good aspect, because oftentimes when you want to ground knowledge that is usually comes through vision, we sort of pair language with pointing, or like, you know, physically just saying like this object is called, you know, an apple or whatnot.
Right, exactly. Another thing that comes to mind that's relevant and is also not a direct answer to your question is we recently did some work where we used essentially Wilbur, so the model that I showed you here that's been trained on static images and associated language that describes what's happening in the image. And we wanted to see if that visual grounding, so now this model has learned how to ground words to visual concepts, right? Different objects and attributes and so on. And we wanted to see if that can be generalized to a situation where an embodied agent, so like a simulated robot, is being given instructions in natural language. Things like go down the hallway, turn right at the red painting, and then go to the kitchen, and so on. And we found that it works reasonably well, that the visual grounding that has been learned from this internet sort of web images does in fact transfer to these embodied settings where the images don't look the same. They're these egocentric images that a robot might be seeing. And that works reasonably well. And so that because the training data was images and associated descriptions that are not all that expensive to collect, maybe that is one example of a way to teach a robot this visual grounding in an inexpensive way by leveraging language such that it can now follow instructions better. You see what I
gotcha.
mean?
Yeah.
Yeah.
Yeah, that makes sense. Thanks.
Any other questions? Right. So I will now switch gears and talk. I think we have a little under 20 minutes. I'll talk about AI and creativity. And so let me try and motivate a little bit why I think this is exciting. And so if you look up what creativity is on Wikipedia, it's defined as a phenomenon whereby something new and somehow valuable is formed. And so this sort of, it can be intangible things like new ideas, scientific theories, musical compositions, jokes, or sort of more tangible things like technological inventions, literary work, paintings, and things of that sort. But it essentially captures all sort of new ideas, new ways of thinking, new ways of problem solving. And so it sort of, to me, it feels very powerful if, I won't walk through all of this, but to me, it feels very powerful that if we can use AI to enhance human creativity, I feel like that could be one of, yeah, that sounds very exciting to me. And so that's sort of my underlying motivation here. I think from sort of more like why should, like from an AI perspective, I think it's also exciting because you can think of it as a test bed to demonstrate intelligence. If you can show that your algorithm has creativity in some way, then it's essentially discovering new concepts or new ideas, and that's one way of demonstrating intelligence. And like I said, if it can help us being humans, think better, collaborate better, solve problems better, sort of express and feel our individuality better, I think that's very powerful. I do want to stress this enhanced human creativity piece. That is a big part of how I think about this. I think about it very much as using AI, using technology to enhance human creativity, as opposed to sort of systems that might just create creative content on their own without thinking of a human in the loop. So I am interested in the human in the loop setting. Yeah, and so let me just jump to the outline for this. I do want to have a disclaimer that this is very early work. So this is sort of very early explorations in several different areas. No one thing is sort of a big groundbreaking idea or project or anything like that. These are just dabblings in those directions. But I still want to share that with you. So let me get to the outline of this and jump right into a few things that we've done here. All right, so one direction that we've looked at quite a bit is generative art. And generative art refers to art that in whole or in part has been created with the use of an autonomous system. And so you can think of interactive generative art, where some features of the art have been designed by the artist, and some features of the art are sort of determined by the autonomous system. So usually it's through randomness. It can also be through the process of training a neural network and what that training procedure looks like. And the interactive piece comes in where there is a user who is not the creator of the system, is not the artist, is not the machine. It's a user who is trying to use an interactive generative art system to create art that they might find interesting. So here's one example. If you think of sort of neural generative art with GANs, then the GAN has been trained by someone. There's a training process that went in. There is a notion of randomness through the noise that's fed in. And there was the selection of the data set. Someone decided what this should be trained on. So all these choices are going to determine some features of what quote unquote art is being generated. But then there can be a human in the loop that is looking through these interpolations, right? And through these interpolations, they're interacting with the system, and they might create a frame, a piece of art in this case, that they are excited about, right? So that's the part that's interactive. It can also be in this non-neural, more symbolic setting where the user is picking these different parameters for the different number of lines and the thickness of lines and the color palette, but the underlying structure has already been predetermined by somebody who built this interface, right? So there are, and there is randomness here. So every time you generate a new piece, you're going to see different instantiations coming from this distribution. So this is generally the landscape of what I'm talking about. And so one question we were interested in is that if you were to observe a user interacting with one of these interactive generative art tools, and if you look at the choices they are making, is there something that these choices can tell you about their other preferences that they might have? It could be other preferences within art, so things like, or within algorithmic art or generative art, things like what color palettes or stroke widths or density they might like, or it could be also outside in terms of sort of painting styles, interior design choices, fashion choices, music, food, and things like that. And so we were just curious to see if there are correlations in these choices that people make as they're creating this art and their other preferences. And so we studied this in the context of this one very specific generative art form where there are a few options. You can change the density, the number of strokes that are in this, the thickness of these strokes, the color palettes, and things like that. And the idea would be that if you tell me which one of these different instantiations you like more, can I make predictions about other preferences that you might have? And so the short answer is what we found is that across subjects on Mechanical Turk, the preferences that you have within this interactive strokes art form that I just showed you can predict other preferences within that same art form better than chance. The chance would be 50%, but it cannot predict other attributes or vice versa all that well. And so there's a few interesting things that you can do going forward. I won't go through all of these, but one thing that I'm kind of excited about is it would be neat if we could learn or discover through machine learning art forms that can correlate with, there are sort of more engaging personality tests, right? Right now there are these personality tests where you answer a whole bunch of questions. It's not a lot of fun to do, but instead if that could be replaced with an art form, and just as we observe someone interacting with this art form, if we can draw conclusions or inferences about their personality type, that could be interesting. I should say that this is a space where you have to be very careful. You don't want to be drawing conclusions about, you don't want to pick up on stereotypes and things like that. So there are ethical considerations here that we have to be careful about, but it might still be interesting to look at. Any questions on this so far?
So, yeah, I have a question. I don't know from exactly, but do you have, so in this case, you've shown like a couple of examples of art where you like hard-coded what were the elements that you could change. I'm sure that artists have some notion of what are like primary colors that you normally use and what are like the kind of like the atoms that you use when you're creating art. So do you have some thoughts on whether like we should maybe put work on trying to understand what are the atoms that we should give like user control over, or whether we can discover this like kind of like this language of art to empower users to kind of like create more easily.
Yeah, I think that would be awesome. And I've thought of those things a little bit, like exactly like you were saying, that the thing that you see on the right, for example, has certain choices that have just been hard coded, and they feel like somewhat arbitrary choices. If there could be a machine learning model that sits even before those choices are made, that can inform those choices so that anybody can come in and create even the space of these designs that would be aesthetically pleasing. I think that would be very interesting. And it has some interesting machine learning challenges, right? That a lot of these choices are symbolic, discrete choices. They're not continuous representations. So thinking about generative models in that space of discrete choices and symbolic representations, along with this cost function that's supposed to capture aesthetics, which is super subjective. I think figuring out how we might do that, that would be extremely valuable, any progress that we can make there. And I think it's also hard to do. So even technically, I think it's a challenging problem.
Yeah, definitely. And the other question is about, and I want evaluation. So if it was already difficult in captioning, I guess that here, like I guess it's mostly like crowdsourcing evaluation, but I don't know about the literature, but are there any like quantitative evaluations that we can make to figure out if we're doing progress in building more expressive art, like more expressive tools for art creators?
Yeah, I don't know of any. I don't know of any quantitative measures to do that. And so for all of the work I think that we've done, we've relied on crowdsourcing, on human evaluation. In the GAN world, obviously there are things like inception score and things like that that people have looked at to try and get some handle on the quality of generation, but those are not aligned at all with art or aesthetics and things of that sort. You could try and convert some of those, like you could train GAN models on paintings and have use that discriminator's score as a score for some sort of aesthetics, and that could give you some quantitative measures. It wouldn't necessarily generalize to sort of the more algorithmic, the thing that you see on the right. Those statistics are not going to match. So yeah, I don't know of work in that space that is that can be used. And so any progress there would also be very useful, because right now we need to keep going back to mechanical turn. Yeah.
Okay.
So I was wondering, I mean, often when, you know, with sort of classical art, you have sort of the aesthetic dimension on one side, but then you also have, you know, meanings and maybe like some subtle political references, or like there's a whole bunch of other stuff just hidden behind the surface, very much sort of according to the intent of the artist. And I mean, it seems so far a lot of the AI art is really just, you know, purely generate pretty or interesting patterns, right?
Yeah.
And I wonder if you have any thoughts of like how could one maybe preserve some sort of deeper intent from the artist side, maybe still allow this interactive exploration, but yeah, I don't know, it just seems that somehow that gets lost in the process a little bit. And so,
yeah.
So do you have any like thoughts or ideas on that?
So a couple of thoughts on that. So one, I think it can still come from the artist, right? And so I know of a lot of artists who actually use AI tools specifically to make certain political, societal statements through it. And so, for example, there was this work where artists came up with very elaborate face masks for the purpose of being able to throw off face detection and face recognition systems to make that statement, right, about the use of technology and face recognition and things like that. So there's quite a bit of work that I think artists do with very much that intent. They use these tools to make the point. Of course, in that case, it's again coming from the human and not from the machine. In terms of, I don't have ideas on what machines can do. One thing that does come to mind is there's this data set by Adriana Kovashka at University of Pittsburgh on advertisements and the subtle points that people try and make through these advertisements. And she's collected a whole bunch of annotations of what symbols are being used in these advertisements and what point they're trying to make. And they are trying to build machine learning models that can try and get to some of this. So efforts of those sort intersecting with art can maybe begin to get to some of these questions. But like you said, I think it's just far, far away from where we are right now. It's an interesting point that you bring this up. I had a slide, I may have skipped through it, or I may have just dropped it, on casual creators. So in computational creativity, they use this term casual creators, which are intended to be tools to be used by people who are just exploring for fun, where they're not sort of trying to design in any goal-oriented way. They may not be trying to make any sort of meaningful statements. They're just interested in finding interesting patterns that they are excited about. And so a lot of the work that I'm talking about falls more in that category, and not in the category of sort of art with meaning, if you will. Yeah. I mean, some might argue that art without meaning isn't even art. And yeah, that conversation could be had, but yeah. All right. So, we have only 4 minutes left. In the interest of time, I'm going to skip to the one piece that I did want to get to, because I'm kind of excited about it. So these are a couple of things, actually, not just one, but so one other project that we had looked at was how can we generate thematic typography. So if the input is the word book and the theme is library, the task was to write out the word book by using icons that represent the theme library in a way that you can still read the word book. And so the approach is very simple. That's what you would expect. But these are some example outputs that we can get out of that, which was fun. Another quick thing that I want to talk about is this work we did on dancing agents, where we take in as input a piece of music, and we represent that in some way. I won't get into the details of it. And then we represent this agent that is going to be quote unquote dancing. It's a very simple agent, but it's very general. So it's just characterized as taking one of k states. And at any point in time, it can either stay at its current state, it can go one state up or one state down. And so over time, it can take these different states, which gives you a movement or a candidate dance that we score in some way. I'm not going to get into the details of that. But once we find a movement that scores well, what's neat about this is you can now represent this agent almost in sort of any way you want, right? Each one of these states can just be an ID of a certain pose, right? So we're not reasoning about kinematics or anything. We're not modeling a human pose at all. It's just this only agent. But once it takes a state, it can index any one of these poses from humans. It can index any one of these 10 sequences of these abstract geometric patterns. It can be indexing frames from a video. It can be indexing photos from burst photography. So it can be really any, if there are k states, then you can have any k visualizations that were in sequence, and the state can index those, and you can have visualizations of dances. So let me show you, I don't think we have too much time, but so here's one. That's a very simple one. So I hope it's not too loud. You might have to change your volume at your end. And so here it's just, yeah. Here's another 1D again, right here is the size. I hope this is not too much for you guys, but yeah. So it's very subtle, probably hard to see much there. And you can kind of see, right? Hopefully you see that the visual changes are somewhat correlating to music. I'll stop this here. And the last one. All right, I think you get the idea. And so, yeah, so this can be really any visualization that's synced with this music. And so this was a lot of fun to work on. there are more examples here if anyone wants to check them out. All right, so we've done some work. I'll quickly wrap up. We've done some work with sketches where we had multiple people come in and contribute strokes to the same canvas. And we've explored what collaboration can look like what are the appropriate collaboration mechanisms. So there's interesting findings here. So if only one person were to draw the sketch, you would get something like this. If many people, let me just click through this. If 30 different people just come in and contribute to sketches, this is what you get, where there's no filtering, but it's sort of qualitatively very different, way more chaotic, but also sort of richer stories. And then if we have this mix of collaboration along with a voting mechanism along the way that helps sort of boost the quality at every stage, you get things that look like this, which are sort of much richer than what an individual would make, but also not as chaotic as the one that we saw earlier. And so we have sort of some evaluation of this that I won't get into. And the last piece is that we had some work on taking in a description of how somebody described their day went, using some NLP techniques to extract what topics they were talking about, what emotions they were talking about, and generating these abstract visualizations of what that might look like, with the idea being that this could be sort of a visual aid that encourages people to come back and journal on a more regular basis. So I think we have some ongoing work on sketches that has fun creatures like this. So if anyone wants to talk to me about this in the next sessions that we have lined up, I'm happy to do that. But with that, I will just give credit to the people who've done much of this work, and I'll just end there. Thank you, and happy to take more questions if there is time.
Thanks a lot. That was great.
No, thank you, Devi. That was great. This last piece, do you have any papers on that?
Yeah, I think everything that I presented in the AI and creativity, except for this very last, except for these doodles, this is ongoing work, but everything else up until this, we do have papers on this, all at the International Conference on Computational Creativity. I'm so happy to share pointers. Yeah.
Okay, that's great.
Does anyone have more questions?
So I have a question about that dancing part. Like how much? I mean, I guess if you go from 1D to 2D, like how much sort of more expressive could you get? And then if you turn it around, if you actually look at people in a club who are dancing to real music, like is there some sort of intrinsic dimensionality to their dance? And what is that dimensionality?
Yeah. Yeah, I have no idea. I have no idea what the intrinsic dimensionality of people dancing in a club is. I think that is a great question. It is useful to think about if we want a dance to be as expressive as we see in humans, what would the state space need to be of an agent that was trying to replicate that? Yeah, I think that's an interesting question. I don't have an answer to that, but it makes a lot of sense. Yeah.
Okay, if there are no more questions, thanks a lot, Devi, again for your talk. It was great.